Hello, thank you so much for joining us for today's webinar. My name is Lynn. I'm a customer service representative here with WarmlyYours, and today I'm joined by
Scott here at Warmly Yours too. How coincidental. Thanks for joining us, everybody.
Yes, thank you so much. And today we're going to be talking about installing snow melting systems under asphalt driveways. So if you have any questions today, please feel free to ask. I know we got some questions that were sent in ahead of time. We're going to discuss kind of near the end of the presentation today. But if anything comes up that you have a question on while we're going through the slides, just feel free either in the sidebar chat or at the Ask a Question module at the bottom of the screen. So like I had said earlier today, obviously we were talking about snow melting systems for asphalt driveways. So we're going to be going over kind of just some general information on our snow melting systems. And then we're going to be going over a project example that we did a while back that was a full coverage driveway heating system. So the entire driveway had heat under it. We'll go over the installation steps, and then we'll also be going over your different control options. And finally, we'll be showing you a example project with just tire track heating. So our snow melting systems are becoming very popular. They're all electric, and they are designed to be embedded in concrete, under asphalt, or in the mortar or sand underneath pavers. So they do come in two different types, two different styles. We have our snow melting cable and our snow melting mat. Scott, can you tell us a little bit more about the difference between the two and kind of just how they work in general?
Well, it's the same. It's the same cable. Just one of them's attached to a mesh already, and one of them isn't. And the one with the mesh is easier to install because you can just roll it out and then cut the mesh and turn the product. What people also and I wore green today just to match the cable color too. But anyway, a lot of people ask, "Hey, can I put this on my wooden deck?" That sort of thing. And this product is not designed to go on wooden decks. This product is designed to be embedded in mortar or asphalt or in sand and under pavers. So it needs to be installed per the National Electric Code. And that would usually entail about 4 inches of non-combustible medium. Inch and a half on top and 2 inches below of non-combustible medium. So you could see if you had a wooden deck and you wanted to put this product out there, the wooden deck may not hold the tons and tons of concrete and sand and stuff that you would need to embed it correctly. So this stuff is designed to go in the product in the non-combustible medium. It's designed and spaced by our engineers to heat evenly. And it can be also designed to come on when it snows, so it's an automatic sensor, and when it has precipitation and when it's under a certain temperature, the system will turn on. When it quits snowing, then the system will go into an after run time and continue to melt the product, to melt the snow after the snow event is over. So what you need to think about when you're talking about snow melting is 2 things. There's actually the snow event, and then there's the after run time. So if you had a control that just turned the power on during the event, say 2 or 3 hours, and you got 6 inches of snow, as soon as it stopped snowing, if you didn't have the after run, it would just stop heating right then. And you would have a slushy mess on the ground or on your pavement or on your stairs or whatever. So what happens is the automatic controllers are designed to run a certain amount of time after the event is over. And that's all time to melt the snow. So you need to make sure you understand how snow melting works. There's the event, and you are going to have a hard time keeping up with the event, especially if it's snowing very, very hard at that point. And that's where the after run time is the time it takes to melt all the snow that was deposited on your surface, be it stairs, walkways, driveways, that sort of thing. We're talking about a little bit later about the difference between full coverage and tire tracks. To the uninitiated, most people, when they come into us for the first time, they will say, "I want to heat my driveway." And what they will do is they will ask a quote for heating every square inch of the driveway. Well, if you have a 20-foot wide driveway by 150 feet, that's probably going to take more power than you have. So that's where we're going to be talking about tire tracks. Tire track coverage allows you to get in and out of the space safely, especially at the bottom of a hill when you're trying to enter onto a street or going up a hill to a house. That's where you want to make sure you have tire track coverage. You don't need to heat every square inch, just enough for the tire tracks to allow your car or truck to pass up and down. So automatically, when you're thinking about, hey, I want to look at getting heat in my driveway or heat in my walkway, what you can do is you can take the square footage of that area and multiply it by 50 watts, because that's about what the coverage is. And then you can take that and you can figure out the amps by dividing that number by 240, and that'll tell you how many amps you have. And you'll probably go, oh boy, that's a lot of amperage. But don't worry, because we can do the tire track coverage, which will allow you to really reduce the amperage and still give you the coverage to get you safely up and down your driveway.
Awesome. Yeah, definitely a good thing to remember. You don't need to do the whole thing all the time. So we're going to be talking specifically today about asphalt applications. So when you're putting snow melting down for an asphalt driveway or walkway or whatever you're going to be installing, it'll be going between 2 layers of asphalt so that it can really efficiently melt that snow and that ice. So you want to make sure that that snow melting system is within about 2 inches of the surface of the asphalt layer. Can you tell us, Scott, kind of how the layers work, or how that is actually going to be installed?
Yeah, we have a couple diagrams coming up here in a little bit, but the National Electric Code requires that it's at least 1.5 inches deep. You have to have at least 1.5 inches cover over the wire to comply with the National Electric Code. And what you can also do is take a look at this job that we're doing here, and they actually could do the entire area because it's not a really long driveway. So they had enough amperage that they were able to do this entire area. Now, you may have a question like Thea, and Thea is asking, can you have tire track coverage but a path from the sidewalk to the front door for pedestrians too? And the answer to that is yes, and that's a great cue, because what you can do is you can also do a hybrid, which is you can heat the first 12 feet outside of your garage and do full coverage there. Then you can do a walkway over to the front door, and then you can do tire tracks out to the road. So there are a lot of people that do that. They say, hey, I want to have enough space in my double wide garage here to park a car on each one and have it melt, and then I want tire tracks out to the road. And we do that all the time. So that's kind of like a hybrid design. And then, of course, if you have enough amperage, you can run a walkway heat to get to your front door. So very, very good question, Thea. Thank you for asking that. So that's what we're doing here. We're doing mats in this particular installation, full coverage, because the driveway isn't a gigantic driveway. They had enough amperage. And if you're thinking about getting snow melting, what you'll really want to do is you'll want to go out to your breaker box and look and see if you have any open breaker space. If your breaker box is full, you're probably not going to be able to add any type of electrical service to any type of electrical product to your house without increasing the size of your feed from the power company. So please keep an eye out for that. That's a good thing to do before you even get started, is look in your breaker box and go, I don't have any breakers, but I still want to do electric heat in my driveway. That's going to be, you're going to probably need either a bigger box or a different type of service. So keep that in mind. That's a good thing to think about when you're thinking about doing the type of heat here that we're showing. Make sure that you have electricity available.
Yeah, if you're doing the whole thing, it could be like Jaws, where you're like, we're going to need a bigger box.
Yes.
I just thought of that one. That's very good. I'm proud of that. Anyway, so moving on. So talking about we had already discussed really the difference between the coverage. So again, the first project, we're going to be showing you that full coverage. The second project, we're going to show you the tire tracks, and really kind of just the difference in how they work. We'll be showing you, actually, kind of once they're installed, what they can do with that snow, how that's going to look once the snow is falling and the systems are running. But I guess the main thing we're really trying to say here is, don't just think I have too large of a space or I don't have enough power, because we're always happy to work with you on making that kind of hybrid system and really taking what's important to you, the areas that are important to you to cover, and looking at, how can we make sure that you're getting that coverage to get the snow gone in those areas.
So Stefan is asking a mathematic question, and I don't have my calculator here, but you take the 800 square feet times 50 watts per square feet. And then you get that number, and then you divide it by 240. That's the voltage, and that'll tell you the number of amps you have. So,
167.
What's that?
167 amps.
167 amps. So there you go. That's a good ballpark. That's full coverage. So remember, you can do partially full coverage, and then tire tracks too. So that's if you're heating every square inch, and that's what a lot of people think about when they're first getting interested in this. I want to heat my driveway. Well, you don't want to heat every square inch of it. And also what you want to do is you also want to think about the heat only travels about 3 inches, 2 to 3 inches at best in a linear manner away from the wire. So you have the wire here, and then it heats about 2 to 3 inches around. So wherever the cable stops, you're only going to get, depending on how cold it is, you may only get an inch extra coverage beyond that wire. It may go out to 2 or to 3, but you have to keep in mind that you just don't heat the center and it melts the whole thing. Same thing like floor heating indoors. A lot of people say, I'll just heat the center and that'll heat the whole floor, right? It won't. It only travels about 1.5 inches, 2 inches laterally that you can count on. So that's one thing to think about.
Absolutely. So these are the cross sections the cross section that we had kind of touched on earlier, really showing you the exact layers of the installation process. So you're starting with 4 to 12 inches of that compacted gravel. Can you kind of tell us a little bit more about, the specifications for that, Scott?
Well, the gravel, you're going to talk to your asphalt. We're not asphalt contractors, so they're going to tell you what the best way to fill that is. The more traffic the area gets, the deeper the compacted gravel has to get. So that's where your paving specialist is going to tell you, hey, this is an area that's high traffic versus an area that has no traffic. But you really need to work with your asphalt companies, because now asphalt companies is not like the old days where they would come put down a binder coat automatically and then come put a top coat down 2 inches and 2 inches. Now they want to come out one time, and in that one trip they want to do a single pour of 3 inches. That is not going to work with the system. The system has to be between 2 layers. So if you're talking to asphalt contractors, the first thing you want to do is you are going to state to them, this is going to require a binder coat and a top coat. The binder coat can be put down by a machine, which means a paving machine. The top coat is going to need to be put in by hand or with wheelbarrows or with a dump truck dumping over the top of the system. So you need 2 layers. There's no way around it. You cannot take one single 3-inch layer. And we're running into a lot of people who are talking to their contractors, and that's what the contractors want to do, and that's not going to work.
Yeah, definitely make sure to find a contractor that's willing to work with you on that. And we always are happy to chat with your contractors too. That's something that I think a lot of times we forget to mention. If not only if you have questions on the potential project, but if you're working with a contractor who just is a little maybe wary, they haven't done it before, you can always give them our contact information, and we're happy to answer their questions and kind of walk them through as well.
Now, when you're doing an asphalt job, I'm sorry, Lynn, but when you're doing an asphalt job, you are always going to assume that you're going to be working with the rolls, the product that's attached to the rolls. And when we come up to, I think we're going to try to maybe watch a little video here, but when we get to that video, you'll see why we do it with the rolls, because the rolls can be pre-cut and they can then be dropped into the area and covered. You do not want an asphalt job where you are starting to run the cable back and forth, back and forth, back and forth, because the asphalt contractors are not going to wait the 7 or 8 hours for you to do a really long driveway, routing it back and forth yourself. So this type of work with asphalt is going to almost exclusively be done with the rolls, and that's why we're showing them here. Now, if you're working with concrete or if you're working with pavers, then you can use the cable. What you do is you just attach it, you pre-attach it to 10 gauge fencing, and then you lay it over to the side and get it all attached, and then you can then lay it on top of the area that needs to be heated, and then cover it with the pavers. But we are working with the rolls here, and you're going to see why when we come up here. So just an example of a full coverage job here.
Awesome. Yeah, great point.
We're getting a lot of questions here. How cost efficient? I can't get into that. I can't tell you until we know the size of the installation. So I wouldn't be able to tell you that. And I'm not smart enough to sit here and compute it for you off the top of my head. But we do have calculators like that on our website. We will also tell you, once we get the plan from you, we're going to supply you with the plan. And on that plan, we're going to see it here in just a couple slides, but we'll show you what the amp draw is, what the cost to operate it is. That's all coming up. So great question. And let's go ahead and go to the next one.
So this is what you're going to, you're going to get some similar information when you receive a quote from us. So this system did use a 240 volt mat, and then the total dimension of the area that they were, looking at heating the full driveway is 488 square feet, and they ended up heating about 469 square feet of that. So obviously this specific project, like we had said, is very close to full coverage, and that obviously can vary depending on what you're looking for. This was a 21,250 watt project, ending up with about 88.55 amps. And then we'll always tell you the full, exactly what breakers you'll need. We'll always tell you the full amperage, full wattage, and like we had said, the operating cost for the system, based on about, averages for electric or for power costs.
Yeah, if we know what your zip code is, we can tell you probably what your cost is per kilowatt hour, and that'll load automatically. So that's going to differ for you if you're paying 12 cents or if you're paying 8 cents or whatever you have to be paying. That number's dynamic and it'll be determined by where you live, by your zip code. So what I'd like you to take notice of are the required breakers. Notice how you have 240 volt GFEP heater circuit, then heater circuit, then heater circuit. And then if you look at the bottom, it says 1 by 15 amp, 120 volt non-GFI control circuit. That one circuit is for your controller. The controller runs on 120 in this case, and that's why it needs to be supplied with that 120 volts. And that's running what we call pilot duty. It's turning on and off a bank of relays. So it's just a switch. So it doesn't use a lot of electricity, and 9 times out of 10, you can take that 120 volt off an existing 120 volt circuit if it's not overloaded with a bunch of things like washers and dryers and that sort of thing. So the control circuit, that's where you're seeing that. What you really need to take note of are the GFEP breakers. Those are ground fault protection for equipment. That's what's required for outdoor snow melting, not GFI. So if you're talking to your electrician, you need to make sure you don't use the term GFI or GFCI. You need to make sure you refer to GFEP. That is class B protection. That is 30 milliamp trip equipment protection. So very, very important to understand that when you're going to get your breakers.
Yes. So this is what the Smart Plan looked like for this project. And Smart Plans are what we offer you. They're complimentary. We can usually get them over to you by the next day, or the next business day. And you will send in a drawing of the area that you are looking at heating, and we'll send back a plan that looks like this, showing you which products we recommend, how specifically they'd be laid out, where you'd be cutting and turning them, and having, a lot of really great information. Your Smart Plan is always going to include information on what we had just showed earlier, the breakers, things like that. So for this Smart Plan, this is actually showing specifically up in the top left, you can actually see where we're showing you to be cutting and turning the mat, as well as how you'll be freestyling the cable.
Yeah, you can never ever cut the heating cable on this product. You can never shorten it. You can never alter the length of it. This product is available in Canada. We sell a boatload of it in Canada. So yes, that's a great question, Thea. We do offer that, and it ships out of Toronto. So that's where our shipping point is in the great country of Canada. The one thing about this installation plan, you can see that there are, all the mats are arranged, all the rolls. We use rolls and mats interchangeably. They all start on the same side. So you can tell the beginning of the mat, it has a triangle. And you can tell the end of the mat or the roll because it has a square. So if you can see, all of those triangles are along one side. When you submit the plan to us, we're going to ask you, where's the power coming from? Is it coming from the left? Is it coming from the right? Is it coming from the front or the back? And that way we design it so all the cold leads can reach into these magic circles. And these magic circles are called junction boxes. And these junction boxes are called out on the plan itself, and the cold leads are only 20 feet long on this particular product. That's not long enough to get from the area over here over to the house. You can see where the garage is. So that length is 24 feet. So what happens is, since that cold lead's only 20 feet, it's designed to be run into a junction box. And that junction box is right here at the bottom. That's junction box number 2. Junction box number 1 is over here in this corner. So it's very, very important that you realize that the leads are only 20 feet. They're only designed to get from the heating area to a junction box. They're not designed to run 70 feet to another location. That's all they're designed to do. You cannot extend the cold leads inside of the concrete or inside of the asphalt. The only way you can join the non-heating lead to the electrical wire that the electrician is going to supply to get from the house out to this junction box is in an accessible junction box. And that's where it has to be accessible. It can't be buried. If you do bury it, you have to be able to take the top off. That's what they mean by accessible, because you're going to need to get in there to test the wires, to set it up and check your connections. If you ever have any issues, you want to check your connections, and it has to be done in an accessible box. So these are the accessible junction boxes that you can see here at the bottom of the drawing. Also, what you want to know is at the bottom of the drawing, for some reason we cut it off and we didn't notice it, is that's where your breakers are going to be called out. That's where your energy use is going to be called out. That's where the number of heating products are going to be called out. So it's there at the bottom. Just take our word for it. I think we just kind of blew it up so we could see the design a little bit better on this one. So just an FYI there on that one.
Scott, do you want to go over the temperature sensor location?
Oh, sure. Yeah, we're going to see in our video a little bit later that there's a big red blob on this. That's where the temperature sensor goes. The temperature sensor needs to go between 2 heating elements, and the 2 heating elements, obviously you can see, are running right next to each other there. So it goes in a piece of conduit that's capped off so no asphalt can run into the conduit, because if that sensor there ever fails, it can be pulled out and another one pushed down in there. We strongly recommend that you use a control that has a sensor that goes inside of the asphalt, because in the middle of the summer you do not want the system to kick on full blast and you not know about it, and now all of a sudden you have the temperature from the sun, and then the system being on, it can actually turn the asphalt into a gooey mess. So that's a couple of things. It's a safety device. And you can leave the control on all summer because it knows what the temperature is, because it has a sensor there. But that's what you want to make sure of. And then also it keeps track of the sensor temperature. So if the system is turned on, but the sensor is telling us that the asphalt is 70 degrees, well, 70-degree asphalt is going to melt the snow. The control doesn't need to be on anymore. So you can set that temperature to what you want it to be, and then it will turn off because it doesn't need to be running if the slab's already 70 degrees. So it's a limit that keeps it from operating if the slab is really warm already, and it's also a safety. In case it does get too warm, it'll turn the system off and it'll keep the integrity of your asphalt. You don't have to worry about that with pavers or concrete because they don't melt. They don't turn soft. It's just the asphalt you want to do it. So that's why you get quoted a specific control with asphalt, because it has this sensor in the actual driveway. And we're going to see it a little bit later.
Awesome. Thank you. So, Scott, this is really your specialty. Can you tell us about the testing of the snow melting system using the Megger and all of that?
So what happens when you are talking to your electrician when it comes to this job? The electrician isn't just going to show up the day of the job and be there for 20 minutes. The electrician, if you take a look at, I'm going to go back to the layers here real quick, Lynn, just to take a look at these two and you kind of get an idea. Here you can see the pipe for the sensor is right there. My mouse is kind of doing a weird thing there in the middle of the page. But that's where the sensor is. And it's there because the electrician put it there. So what happens is the electrician has to be there in advance of the asphalt people, because they have got to size the conduit, they've got to bend the conduit, and they have to be ready to go, because if we take a look, we haven't really talked about this picture, but this picture has the binder coat already down. So that's why you see the exposed pipe here. The pipe is going to go above the binder coat into the top coat. So that's why the electrician has to be there, but he has to have all this stuff done already, which means he's probably there the day before, cutting and sizing the conduit, getting it bent so it's in the right place. This electrician was here a day or two in advance, and he had already sized the conduit, he had cut it and placed it here, getting ready for the asphalt people. So if we know that, we know that the sensor is going to go in this top layer of asphalt. That means he's got to, as the contractors that are putting the first layer down, the electrician now has to get busy, and he now has to put the conduit pipes in the right places that he's already cut, that he's already bent, and he's got to get them on top of that binder coat, but not sticking up too high because it has to fit in the finished asphalt layer. So that electrician has already done that, and he's just going to do everything he's already cut and pre-sized. He's now going to lay it in place after the first layer is done. So he's going to be doing that. He's also going to need to test the product before, during, and after the installation, and he needs to test it with a mega ohm meter. And a mega ohm meter is an insulation tester on the wire. It's very, very important if you don't want GFI problems, is to make sure that there's inside the wire, inside the heating cable, there's actually 3 items. There's 2 heating wires and a ground. So those 2 heating wires always have to have a continuous circuit, but they always have to be isolated from that ground. And that's what the insulation of these 2 wires, it separates the wires from each other, and it also separates the wires from that ground. So what the guy's doing with this thing is he's shooting 500 volts down the wire to make sure that the power is not jumping from the current carrying wires to ground. That's an insulation tester. It's testing the insulation layer in the entire cable. So that has to be done before, during, and after. Because if he says, hey, I can see whoever is just standing on that cable, we got a bad reading on that, and it's probably the guy that has the rake with the really sharp tongs, and he had probably just hit it, because I've seen that. I've also seen people that are not paying attention with shovels, so you need to really watch out. We're going to talk about that here in a minute. But that's what the mega ohm meter is. You need to have one of these things. You need to get an electrician that has this. So when you're talking to the electrician the first time, you need to make sure that you're talking to them. You're going to be out here a day or two in advance, getting the pipes done, measured, bent, going to where it needs to go, getting the junction boxes in, because he can't do that while they're putting the asphalt down. That has to be done in advance, and he has to bring with him a mega ohm meter. There's no way around it. It's required by the installation manual.
And we always recommend making sure that they know. I think I've come across more recently a lot of electricians who are not expecting that level of interaction for the project. They really are. I think a lot of electricians are used to coming in, wiring something up, and leaving. So make sure that they're aware of kind of what the expectations are for that project.
And that electrician's also supplying the wiring to get from the junction box back to the relay panel inside the garage. So they need to also do conduit to each one of those junction boxes. So they've got to get that. That maybe can wait, but you have to have the junction boxes there, and you have to have the conduit from the junction boxes to the heated area. That absolutely has to be done in advance.
It does. And again, same thing, if your electrician has questions or you need help explaining it, just reach out to us.
Right.
So looking at this is another really great cross section. So we're showing you again that 4 to 8 inches of the compacted gravel, the crushed aggregate, whatever you really want to call it, and then that base asphalt, again 1.5 to 2 inches, the system, and then 2 to 3 inches of. Are we saying 2 to 3 inches? I thought we were saying 1.5 to 2.
For the base?
For the finished asphalt.
Oh, the finished asphalt, yeah. I mean, it's usually going to end up around 2 inches thick on top. It has to be at least 1.5 inches by code. So that's a good, as long as you're 2 to 3 inches from the top surface, that's okay.
Okay. Just wanted to make sure we were on the same page there. And then, so that gravel layer, again, you want to make sure that that's spread very evenly, that foundation is nice and even, nice and ready to go. The system really is going to be, I usually say, as good as what it's installed in. So you want to make sure that you're getting a good foundation for that asphalt. And then again, that you're talking with your asphalt contractor about how much gravel, how how many different pours they're going to be expected to do, and things like that.
So Stefan has a question about no need for electrical permit or inspection. Whenever we quote these jobs, we in our documentation we state that the job has to be installed per your local code. So if your local code requires an inspection and a permit, then yes, it is required. But unfortunately, we can't keep track of the 5,000 municipalities in the U.S. alone. We have no idea what local codes are, and that's why your local electrician will tell you the size of the wire you need, what gauge you need. They will figure out the voltage drop depending on how long the runs are. That's all done by the electrician who's going to be responsible for installing this per the local code. We have a question about how easily can we maintain this system, and that dovetails perfectly with the person that asked what kind of efficiency or what kind of responsibility comes to the homeowner when it comes to PEX tubing for the hot water systems. The hot water systems are maintenance installations. When you put them in there, you're going to have to maintain the valves. You're going to have to maintain the pumps. You're going to have to maintain the boilers. You're going to have to maintain all that stuff and the PEX tubing and any leakage that you may have of the glycol into the ground. That's all stuff that you're going to have to take responsibility for as an owner. When it comes to electric, there is no maintenance. You don't have to update anything. The only thing you have to do is if you have an automatic controller, you have to clean the sensor off every fall before the winter, because birds love to sit on there, and we all know what happens when birds sit on things. So you need to make sure that little disc on your sensor is clean, and that has to be cleaned every year, and that's the only maintenance you have to do on this particular job.
That's definitely a big plus. Once it's in, and you're good to go. And Stefan asked, what is the longevity of the system, assuming normal use and there's no earthquakes or any kind of crazy act of God happening?
It will probably last longer than the medium it's in. So you'll see concrete cracking and that sort of stuff, and asphalt need to be repaired after 10 or 15 years. This product will probably last much longer than that. So you just have to make sure it's a quality job. I mean, our old office was in a business place that had PEX tubing installed in the parking lot, and it had been done like 20 years ago. And where they hadn't done any patching, you could actually see the remnants of the PEX tubing coming up because people were driving over it, because it's simply the top layer had worn away. And that is the same with anything. Our product will probably last longer than the top layer or the integrated part of the driveway itself. So there is no worries when it comes to that, no maintenance. But you need to keep in mind that the system is only as good as the medium it's put in. So if you put it in a substandard asphalt pour, the substandard asphalt pour is not going to last very long. And as the asphalt starts to buckle up and balloon and that sort of thing, it's also going to put stress on the cables until it finally gets to the point where it bottoms out so far that you'll be driving on the cables. That's just what happens, and that's why we say it'll probably outlast the system it's the driveway that it's in. So that's one thing you want to look out for, but that's a great question.
Yes, thank you. So again, talking about the asphalt layers, you can see that they put that base layer down, then they put the mats down, and then they're putting that top layer. And this is where we really want to drive the point home of not using a paving machine for that top layer. That is fine for the base layer, not a problem. Obviously, when you are putting down the top layer, you want to treat it with kind of like with kid gloves. This is a system that is going to be needed to, be a little gentle with it. You want to you want to hand shovel that asphalt. You can use a rolling machine, and you also want to make sure, or you can even use, you had said, Scott, like wheelbarrows or a dump truck to do the pour. And one other tip, and I don't know if we have it mentioned later, but I think it's a good one, is wrapping the shovel and the rakes, whatever you're planning on using, with a little bit of duct tape on the ends to try to protect the cable from the metal shovels.
I've had to go out and repair one or two spots that got hit by a shovel. So, I mean, you can do it if this product gets hit by a shovel. That's why the electrician is there with the mega ohm meter all the time. So he can go, whatever you just did right there, you need to stop. And then what you can do is you can make a foot or a foot and a half perimeter and continue paving around that. And then you can leave that area open and then we can get it fixed. So if there's ever a problem with this, it's just like floor heating. We can find the spot where the damage is and then we can fix it. I've repaired multiple asphalt driveways and it's simply because it got damaged, usually by a rake, because a rake is very, very sharp and at the end it's like a pin and they just go boom like that into it to move that asphalt, and that strike right there is usually pretty damaging. So what we suggested with the rakes is turn them upside down and then rake it with the tongs up, or the tines up, I should say. So very, very important on this top picture to notice that base layer may look like dirt. It's not dirt. It's asphalt that was put in there a week in advance so the electrician could get his heights right, because he had to bore holes into the side of the wooden structure there to the left. So he needed to know how high it was. So they came and did the base layer first. That's why it looks like dirt, but it really is a base layer of asphalt. And then the top layer you can see going over the mats.
Cool. So this is where the smart plan really comes into play, is installing or laying out your snow melting mats and really going into it knowing ahead of time specifically how and where you're going to be laying these out. So again, you want to make sure you're testing your mats at this point, that you are making sure that the ones that you're putting down are working properly and nothing happened. And a really great way, I mean, I think they did this in this project specifically, and it's a really easy way to do it. They took that smart plan, laid it out, cut and turned the mats ahead of time, and then had them off to the side so that once they were putting down that final layer of asphalt, they could just move it over, pick it up, slide it back onto the driveway, and it's good to go. They already know that the measurements are correct, that it's cut correctly, and that obviously that it's working. Is there anything you want to add to that, Scott? I know that you have actually done a little bit more of these installations.
Yeah, the thing is you want to make sure that you get all your cuts and turns done as much as you can in advance, because just like we see there, the asphalt truck is there. The asphalt truck is waiting for them to put these over. So you need to move fast, and this stuff all needs to be done in advance. So you can see they're laying out the two runs here that are actually one long roll. And then to the right of the installer in black there, to his right, you can see where there's another mat, a roll that's been cut and is ready to be put in there, cut and turned. You can never ever shorten the heating cable. And you don't have to worry about any chemical reactions with our product in the asphalt or the concrete. There's no chemicals really going on here. It's pretty much inert material being inserted into a non-combustible medium. So you don't really have to worry about that. It's not like glycol when it comes to a leak in a PEX system. But at the bottom of this picture, you can also see the junction box there. And the junction box is that bluish grayish square at the bottom. And you can see that there are one or two cold leads coming out of there. We call it the spaghetti bowl, because that's what happens when you're out doing this. You're just getting these things in and you're pulling the leads through the conduit and you're just pulling them through the box. And while you're doing it, it looks like a spaghetti bowl. It looks just like a bowl full of spaghetti until the electrician comes and trims the wires down to make his connections. So you can see that there. And what they're doing is just putting this one down. And then when this one's laid down, they'll come dump some stuff on it. When it's covered, they'll lay the next one out and they'll just keep going like that. And you can cover a lot of space as long as you've got this all cut and turned the way you want it before the asphalt people show up. You will not be able to do this with cable.
Yes, that's a good point. So there is that spaghetti bowl. It kind of looks like a spaghetti bowl exploded, but that is what it's actually going to look like when all those cold leads are routed through that junction box. And again, these cold leads are designed to be long enough to reach these boxes, not necessarily to go all the way back to the initial source of power, but to these junction boxes. That's the main thing to consider. And then all of these splices, any extensions, anything that you're working on with this, with the cables, with the cold leads, needs to be done in these junction boxes. And again, like we'd said, accessible junction boxes, that they are above ground or they have a lid or something so that they're able to be accessed if needed.
Right. And also sometimes, in the real world, I've done dozens of these installs. In the real world, sometimes the electrician doesn't have the conduit to get from the house out here to the, it looks like actually a bowl of those 4th of July snakes that just,
Yes.
that they go everywhere. So what happens is sometimes you might have to leave the cables coiled up, accessible somewhere. If you do ever have to leave the coils, the non-heating leads out in the open, always make sure that you plastic bag the ends. You do not want any water getting in the exposed end of the non-heating leads. Everything else is waterproof except where the wires stick out, where those 3 wires that stick out of the cold leads are. So you want to make sure that those are waterproof, so you put a bag around them. And if you need to bag each individually or then bag them, gather them all together, then bag them again. But usually you're not going to have to do that. But in the real world, I know I've had to do it myself. You've got to bag the ends to keep the rain from coming and getting inside of that water. It'll throw off your mega ohm readings if they get wet. So right now we've got these things set up. You can see that that's a wooden retaining wall that they had to bore through to get the conduit through there. So you can see what has gone on there, and now they're going to be waiting for the electrician to trim those excess leads and make his connections and run that from that box over to the garage on the left. So that is that's how you get the system all wired together. Each one of those links there, each one of those is going to have an individual feed from the relay panel. So if you see 6 of those wires, there's 6 leads coming from the relay panel to reach those. So that's why the conduit has to be sized appropriately so you can get 6 leads through there. It's not just 1 lead and then 6 cables attaching to it. It doesn't work that way. You'd have to have a wire that's that big. You can't do that, but that's where you get the individual feeds coming through that conduit. So your electrician is going to have to think about what's my voltage drop, what is my conduit fill rate, all that kind of stuff. They are there to figure out and install it per the local code.
Awesome. And then talking about sensors, talking about the control, we kind of touched on these briefly. So for this specific project, they used our premium snow and ice control. It has a Snowmelt aerial sensor, and that's the sensor Scott was talking about earlier. That's going to be installed above ground somewhere, often along a roof line, or sometimes people will do it kind of in the ground near the driveway or the application. One thing to keep in mind with the location of that aerial sensor is making sure that it's somewhere that's going to get similar precipitation as the driveway. Obviously, depending on where your driveway is located, snow that is blowing or snow that's falling may not be happening on the back side of the house. So you want to make sure it's somewhere relatively close by. And then this control has that hold on feature that we talked about. So it's actually going to continue running once the sensor detects that anything falling, any precipitation has stopped, or that it's warmed up, and it will let it melt fully, so you don't turn into basically an ice rink on your driveway.
Yeah. Excuse me, I always get choked up during this part of the presentation.
It's just so beautiful.
It is lovely. The reason why we've chosen this one is because it has the slab sensor. So if you look at one of those knobs on the front, there's 2 knobs on the front in the lower right corner. And if you take a look at those, you can see one of the knobs is for the after run time. It's what allows you to set it from 0 to 12 hours or 0 to 10 hours. That's the amount of time that it's designed to stay on after the event is over. Then also the other knob is the slab sensor temperature, where you want it to always kick off when the slab sensor reaches 70 degrees or when it reaches 60. If you set it down to 30, your system will never come on, or it'll come on for a little bit and then turn off. You want to turn it up till it's like 60, 70, or 80, just depending on where it is. And there are no 2 exactly the same installations. So whenever you're getting one of these products, one of these controls that has a knob that turns from 0 to 5, let's say from 7 o'clock to 4 o'clock, you always want to set it in the middle, because then you can adjust it down or adjust it up. You never set it all the way down, and you never turn it all the way up. It's designed that way for a reason. Here's the maximum and here's the minimum. Put it in the middle, and then you can begin to fine tune it. One snow may be different from a different snow, but your control, your installation is obviously going to be different than your neighbors or than the people that are living in Seattle as opposed to Washington, D.C. or wherever. those knobs may need to be adjusted per your installation. So you may experiment. We tell people the first year they have it, oh, it turned off too soon. Well, then turn the after run time on a little bit further. And oh, it was almost right that time. Then turn it on just a little bit further, and then that will work. Because what we're trying to do here is not melt the snow by itself. We're trying to get the snow to melt. We're trying to turn it to water, and then we're evaporating that water into the atmosphere so you have a completely dry surface. You don't have that asphalt with ice pushed down in it or that black ice. If your system is melting but it's leaving back behind black ice, you need to turn the after run time a little bit further so that is evaporated, because what you'll get with a properly running system is one that will be completely dry when it's done.
Yep.
Also, a 36-inch dumping of snow is not normal. So people will go, we got 36 inches of snow and my machine turned off too soon. Well, because 36 inches isn't normal. It's not average. So there's always going to be extreme cases where you get a whole bunch of snow and you may not melt it for the first run. That's why there's a little switch on there that lets you turn it on and off manually. If you want to, hey, I'm going to turn it on again and I'm going to turn it off when it melts, you can do that. But a 36-inch snowmelt deposit is not the same as a 2-inch snow event. So keep that in mind. It will operate differently depending on the amount of snow you get.
Absolutely. So this is a really great kind of diagram showing how the control and the sensors are all wired up together, all wired back to, from the cables or the mats to the J boxes, the junction boxes, to the relay panels, to the breaker panel. Scott, is there anything in this that is particularly important or you think we should be touching on?
It's all important.
Okay, fair enough.
But it's very, very important. Notice how the relay panel is marked inside. Notice how the breaker panel is marked inside. The controller is mounted inside. The remote control override, if you decide to buy one of those, is inside. Now, the controller that we just looked at is got I think it's a NEMA 3X, which is outdoor rated. But who would want to make their customer walk out into the snow to manually turn their system on and off if they need to turn it on for a little bit longer? You don't want to put the control outside. You put the control inside. The relay panel is a NEMA 1 type enclosure, which means it has to go inside. So it's not rated to be outdoors. But those junction boxes are, the heater cables are, and the sensors are designed to be outdoors. So that's why this drawing is so important to keep in mind, that the stuff marked inside needs to be in the garage or in the basement or wherever. And we had I'm going to hit start answering this question from Guy. Guy asked, a fresh asphalt is hot, very hot. Will it melt any of the mat components, including the heating wire insulation? This product is rated up to 434 degrees, so it will withstand anything up to 434 degrees. Now, obviously, the little mesh may melt, but the mesh is only there to hold it in place while it's covered with asphalt. Because once it's covered with asphalt, that part can melt. If it does, I don't think it does, but even if it does, it doesn't matter, because all its job was to hold it in place until the asphalt covered it. So you don't have to worry about that mesh, but the heating cable is rated up to 434 degrees. So very good question. That's Guy, and we appreciate that.
So probably don't pour lava on it, but hot asphalt should be fine.
Right. A lot of people like lava. I'm allergic. Okay. So let's move on to the next slide, shall we? This is a beautiful place. This house was awesome. It was right down by the lake. As you can see, the lake there is in the background. Beautiful. So it was great, and it was a great day. This is one of the rare days where you actually go to do an install, and it's beautiful out.
Usually it's like just hang out outside, watch everybody do that install. It looks great.
It was a beautiful day that day.
So are we going over the video, Scott? Do you want to pull that up?
Yeah, I would really like to go through this video, because it's like the whole job, from the base coat on, and it's only just a few minutes long. So hopefully we won't bore anybody. But before we leave, you can see that there are the junction boxes right here along the way. There's our spaghetti bowl, 2 of them on each side. And you can see it's just a beautiful driveway with a drain right in the middle. So let's see if this plays.
So far, so good. Yes, this video is on the website, and actually you can see we're actually on the website right now. And if you go to the Explore tab in our website, there are lots of videos, not just this one, lots and lots of videos on installation, troubleshooting, pretty much anything you could want to watch is on that website.
There's our sensor. Junction boxes, sensor at the top.
Dry fitting the system is something we didn't talk about much, but it is always a good idea. Obviously, we had said, kind of looking at laying it out ahead of time, making sure that everything is fitting, everything is correct and ready to go.
The National Electric Code requires rigid conduit or any locally approved means. So if your locality says PVC is okay, that might be all right. But with asphalt, it's pretty good chance of melting. So you might want to use rigid as required. So if you look here, you can see this is why all the mats aren't laid out at once. You only lay out one run because these guys are going to be physically doing it by hand. So you can't drive over the heating mats either. So you can see that they've laid the mat out, they dump asphalt over the top of it, they work it, and then once that area is worked, then they come back with the high boy or the dump, whatever you call it, and drop the asphalt there.
And we should say you can't drive over it when they're exposed. Obviously,
Right.
That is a question I get a lot, is can I drive over it? And I usually say, yeah, we wouldn't put it in a driveway if it made the driveway unusable.
Yeah, your driveway is going to look great because no one will ever drive on it.
No one will ever
Awesome.
use it, right? And I love watching asphalt go down. It always looks so smooth and silky. I don't want to touch it. I don't need to burn my hands off, but I do think it's kind of cool looking. So again, making sure that it's at least 1.5 inches thick, 1.5 to 2 inches tends to be a really good number for it.
But notice it's okay to drive a machine over the top of it now when it's covered. So what they're doing now is they're checking the pitch to make sure that the water goes in the drain like the whole thing is designed to do, and success.
And Stefan asks, is there a contractor's discount? Yes, absolutely. We do have trade professional discounts. So if you are a trade professional, reach out to us. We can get you set up in our system. And depending on, how many projects you normally do, a couple different, questions we'll ask you. Discounts can range anywhere from, I believe, 15 to 30% off of MSRP. And then the other question is, what are some of the green or low carbon aspects to be used to sell to customers? And one of the main ones is it's electric. You can get your electric really from anywhere. I mean, if you have solar, you can use that to power this. And it tends to, obviously it doesn't take a ton of power to run. It doesn't cost a lot to run. Is there anything you want to add to that, Scott? I feel like there's something I'm missing.
People always ask, will this work with solar? Well, you can use wind turbine, you can use solar, you can use water, whatever you want to do. We don't care how you get the electricity. It just needs to be, this particular product needs to be fed 240 volts. It doesn't run on 5 volts or 12 volts or 24 volts. It runs on 240. So you'll need an inverter to get it from batteries out to the driveway. But we don't care where the power comes from as long as you can get us 240 or 120. So that's the main thing. It'll work on anything.
You could put your dog on a treadmill and wire them to it. They're really fast. You get a husky, they have enough energy. So looking at the full coverage, or the full coverage project cost breakdown, I should say. So again, this is MSRP. So obviously if you are a trade professional, you're looking at lower cost total. But so for the mats themselves, you can see that with the control, the aerial sensor, the Snowmelt plaque, which we didn't talk about much, but that's something that you want to put in the driveway and the pavement, just so that for future reference, if anyone ever is working on that driveway, they are aware that there is an electrical system beneath the ground and to be careful with it. And then obviously also those two, or that, was there two relays? One relay, one 2-pole relay. And so the total came out to $8,149.
Okay, so we got a question about what's the IP NEMA rating of a junction box. That is going to be determined by your electrician. It's either going to be 3X or 4. So it's made for outdoor. Your electrician can make sure to spec the correct one. So that's a great question, and very good. Thank you for asking that. So let's move on to the next one, and let's talk about tire track coverage.
I am excited. Let's do it. So again, this was using a snow melting mat, 240 volts. So the total area of this project, or the area that they're looking at heating, was 840 square feet. And obviously that is a lot of space to cover. So we brought that down to a heated area of just 330 square feet. So that total amperage is 62.57 amps, 15,000 watts. And then again, obviously all those breakers, making sure to have those GFEP breakers where needed. And then also that one non-GFI circuit for the control. And so for the tire tracks, you're looking at about $1.75 per hour, or for, let's say it was 8-hour snowfall, you're running it for 8 hours, you're looking at about $19.
So yeah, you think about, you pay a kid to come shovel your driveway, you pay him 20 or 30 bucks. It's about the same price. However, you have a completely dry and a completely clear driveway. So that's one thing that's a good ballpark. Let's take a look at this smart plan for this driveway. And you can see that we've done tire tracks here. What I also always want to direct you to looking at are the triangles. The triangles are the start of the rolls. So notice how all the triangles are bunched up there. And the reason why is the relay, or the junction box, is over here. So all of these leads are designed just to get from this over to the junction box, which is over here. So you can see that we kind of started from this direction and ran our product this way and then ran it that way. And that is very important to keep that in mind when you're doing this with the installers. So anything you'd like to add on this one?
Oh, I think that's good. We did get a question.
Oh, okay. I need to find my mouse. Okay, I found my mouse. Return on investment of a simple project like this. I don't know how you measure ROI with customer satisfaction.
It's a good question.
Yeah, and to be honest with you, I'm in tech support, so people only call me when they have trouble. So no one ever says, oh, you know what, this is fantastic, this is the best thing ever. The return on investment is how happy it makes you. I mean, because it eliminates you having to shovel. I mean, I hate shoveling. So the ROI for me is going to be quite astonishing. But do you have anything there? Have you ever gotten that question, Lynn?
I have not, but I agree. I actually just usually don't shovel and just kind of compact the snow as I drive over it. So for me, that would be a huge, awesome blessing to have the driveway clear, or even just have tire tracks. So yeah, I mean, customer satisfaction, obviously I do customer service, and I do hear from a lot of very happy customers with it that are, maybe adding another area of heating, or are, doing a walkway now. And so they've had a driveway that's heated for a few years and they love it and people rave about it. So it definitely tends to be a very popular and very well received system.
Yeah, Eric says the only way to figure out ROI would be knowing how much it would cost to remove the snow and how often each year.
Right.
It costs you $20 to have a kid do it, about $20 to melt it. So I would say that it would be pretty much a push from the beginning. But as Eric says, a lot of people that buy these aren't. It's hard to measure the ROI, so they're not going to be, too fed up if they only get. I would guess if I spent money on this and it only snowed once, it's like when I bought a snowmobile and then that winter it didn't snow enough to use it. My ROI on that was 0. So you got to be. So are you happy that you have it and you use it, or are you happy that you have it and you didn't use it? So all these are great questions that we may have to do a separate webinar on.
Yeah, I really like these. And then Thea asked, wondering if a real estate agent would know if this is a selling point, especially with baby boomers and those wanting to age in place. And yes, absolutely. I think that that is I mean, I actually get a lot of people who are calling in saying, I'm going to be selling my house, and we have a steep driveway, or we have something that is hard to shovel, and we want to put this in specifically for selling the house. We're not going to be able to get much use out of it, but the next homeowner will definitely be able to. And we also get a lot of people calling, looking at either for themselves or like for their aging parents. They don't want them walking on a walkway or, something that's going to be icy. So putting that in is definitely a huge plus.
Yeah, the cost per square foot is not something to get hung up on because, once again, we don't heat 100% of the area. And especially with tire tracks, we only heat a certain percentage. So the cost per square foot is best done when you get a quote, because it's definitely based on the more you buy, the less expensive it is. So that's definitely something you want to look at. I don't have the answer for it right here.
Yeah, it
So
can
let's
vary.
take a look at the tire track layout. But great question, Stefan.
So here again, they followed that smart plan. They spaced the snow melting mats at about tire width, which is again on that smart plan. That's pretty much your holy grail. You want to make sure that you're following that as close as possible. They put down that base layer, laid out the mats, and then they have that final layer of asphalt over the top. When the system turns on, like Scott had said earlier, it's going to just heat the area that has the snow melting mats. It's not going to expand, especially far from there.
So let's take a quick look at this video.
Absolutely. I love these. I love the time lapse videos. Yeah, it just keeps up so well, and it really is able to make it so much easier to get in and out of the driveway. And I think this is a really great example too of really how you don't need that full coverage. I mean, if you're looking at that, if I was looking at that driveway about to drive into it, I wouldn't especially feel like I wished the driveway was fully covered. That's more than enough to get in and out easily.
And as time goes on and the sun hits it, that area down the middle will get melted.
Yeah.
So, it eventually will go away unless you get 36 inches of snow. And once again, 36 inches of snow is not average and it's not normal. So you have to consider each individual event for what it's worth.
Absolutely. So for this project, it was about $5,482. Again, that's the MSRP, and that's covering the mats, the control, the sensor, the plaque, and the relay panel.
Yeah, the plaque is required by the National Electric Code.
Yes.
That indicates that there's heating wire in the under the surface.
So some tips for putting down asphalt with snow melting. Again, like we had said, using a megometer to make sure that this is properly tested and properly working before putting anything permanent over the top, making sure your electrician has that and is aware of it. Using duct tape on the edge of shovels or rakes, making sure just to kind of minimize sharp edges and to make sure that everyone working on the project is aware of, how to treat this pretty gently. And then also being sure not to walk on or bend the factory splices. So where there's actual splices where the mat meets the cold lead.
Yes, where the mat meets the cold lead is that you have the heating section that's out in the driveway, and then power has to get to it somehow. So what you use is a non-heating lead to get power from the junction box to the heated area. But that area where the lead is, it meets the heating section, about 6 inches long or so, and it's pretty thick, and that is where your connections are actually connected. That's obviously where the connection is made. There, and at the very end, you'll see a black cap at the end. That's not a sensor. That's just the termination at the end. So that thing, if you take it and you forcibly bend it, you can destroy it because you're taking apart the crimp connections that are in there. So it's it's done to a very, very scientific rate of, smashing it, the right pounds per square inch. All that stuff is done on a calibrated machine, so it has the highest success rate that you can. But the thing is, I have been on a job where the electrician had the cold lead and he tried to bend it to get it in the conduit. So he did that on every single mat, and he destroyed every single mat. So I had to go out there the next day, and it was about 95 degrees in the middle of the summer, and I had to replace about 6 mats in an area about this big. I did it by myself. But the only reason it failed is because they took that factory splice and they bent it, and then they shoved it in the conduit. Well, the part of the moral of the story is the factory splice can't go in the conduit anyway. It's against the National Electric Code to do that. The factory splice has to be 6 inches away from the conduit, so it can't be traveling. No heating wire can go in the conduit. So what they did is they broke the system and they tried to get the lead in the conduit, which is a double no-no. So I will never forget that day as long as I live. I think I lost about 10 pounds that day. But that's what happens if you try to bend the splice. The splices is the area where you have to watch out. You can walk on the non-heating leads, you can walk on the heating cable, but you do not want to walk on the factory splices or try to bend them, because you can do a really bad thing to them. So we have a question here, and then we're going to be wrapping up here pretty soon, aren't we? So let's see.
We are. Can you share the presentation so we can share it with our colleagues? I believe we can. Olivia, do we have a way to do that? All right, yes, we can do that. So Olivia will help take care of all of that. She is our webinar expert. All right, Olivia will reach out to you and get that presentation to you. So if anybody needs that, just be sure to let us know. So are there any other questions? Obviously, we've answered a ton here. Do we have any that were sent in earlier, Scott?
Yes, one question is from David. Can you use this under a wood or composite deck? And hopefully we address that, and the answer to that is no. If you're looking to heat a composite deck or a wood deck, you're going to need a product that's designed to install over the top of it. Our product has to be embedded in, hopefully we know this by now, in non-combustible medium. My number 2, my asphalt contractor mentioned a sticky cloth that can be used over the heating wire to hold it into the base layer of the asphalt. What do you think? I think that's not needed, Robert. Great question, because what we do is, you can see by the video, we can see that the product is laid out and covered with asphalt, and it's held in place by the asphalt. So you don't need anything else. You simply lay it out, and you can, if you'd like, you can take a shovel of asphalt and put it where where the leads are, and you can put it on each corner, and just by laying the asphalt on it is going to hold it in place. So great question, Robert. Number 3, can this be done for a concrete driveway? Absolutely. This can be used for asphalt, concrete, and underneath pavers within sand or mortar. Another great question. Number 4, which is better, asphalt or cement? Also, will tire chains cause any problems in the future? We talked about damage to the top layer. Anything that damages the top layer, you want to kind of stay away from. I would say that tire chains are probably safer to use with concrete than asphalt. Which is better, cement or asphalt? That's up to you. But I do know that cement is probably going to last longer. The one thing you want to keep in mind is when you're doing an asphalt job, a cement job, if you're interested in that, is you have to tell us where the expansion joints are.
Yes. Because
we have to design around them. And I think that goes into the next question. What's the longevity of the install? Julie asked that. We talked about that before. It'll probably outlive your surface. And the last question was affordability and maintenance will be high on the list of questions that clients will ask us. So hopefully we did talk about the cost and the fact that there is no maintenance. And that's Thea. Thank you, Thea, for supplying that question to us in advance. And hopefully we have answered that for you.
Yeah, I think a main point that often people are concerned about is maintenance, and I think that's one of the biggest selling points of electric over hydronic is that there isn't maintenance. Once it's in, you're golden, you're good to go.
All right, I don't think we have any more questions.
Not seeing any. So thank you so much for joining us. I know I had a blast. I always do talking about electric heat. So we'll be back with another webinar on May 12th. Again, it's a Thursday at 1 right here on Crowdcast. And it's going to be all about pairing electric floor heating with luxury vinyl tile. So definitely join us for that. It's going to be a really great presentation. Stefan has one more question.
Yeah.
Sorry.
Yeah, one more
Go ahead.
question. Go ahead and ask it.
Would we put rigid foam insulation under the system if concrete is used, Scott?
Not needed with electric, because hot water, as soon as it leaves the boiler, as soon as hot water leaves the boiler, the temperature goes just like that. And as it goes through the concrete, it gets colder and colder and colder and colder. So to fight that, people have been putting rigid insulation underneath hot water systems for years. With electric, it's the same temperature at the beginning as it is at the end. It doesn't cool off, so you don't have to worry about that. You can do rigid foam insulation if you like, but with electric, it's not required. So hopefully that answers your question.
Awesome. And we do offer short informational daily trainings every day. These are often hosted by me or by Scott. So this is something that's going to, basically 5-10 minutes. Feel free to pop on in, learn a little bit more about that day's topic, and ask any questions that you might have. And we are offering several of our smart services here. So we have services to really help you out. We have a measuring service. We also have remote or on-site installation support. So even if you are out of our service area, we can always help you remotely through a FaceTime or Zoom call to kind of look over your shoulder while you're doing that installation, make sure everything's going smoothly. And then, of course, we also offer installation and troubleshooting for floor heating and snow melting. So our monthly promotion is 20% off of our Lava Radiant panels. So visit our website to learn more about our panels and that discount. And we really value your feedback. Right after this is over, you're going to be receiving an email kind of just asking about your experience, any thoughts, comments, suggestions. We love to hear from you. We want to make sure we're doing topics that you are interested in and enjoy learning more about. So be sure to let us know if we can do anything better or what you liked about today's presentation. Or if you just really want to compliment us on, our hair or something like that, we'll take it.
Oh, the wind is blowing like 70 miles an hour here, so please disregard that.
And of course, if you have any questions, just reach out. You can always give us a call, shoot us an email. Our website has a lot of information on all of our products. Our Facebook, our Instagram has a lot of information, a lot of great project examples. So just feel free to reach out however is easiest for you, and we'd be happy to chat. And that is all we have. Thank you so much for joining us. Again, my name is Lynn, and I am joined by the wonderful...
He couldn't make it, but I'm Scott. So thanks for watching, everybody.
And until next time, as always, stay warm.
And be radiant. Take care.